Gabriel!
Subhashan, what was that for?
For fun? What are you doing, Gabriel?
I'm examining the egg.
Why would you examine an egg?
Well, I wanted to find out if an egg came from a chicken or a chicken came from an egg. Duh.
I have no words to respond to that, Gabriel. So, do you know, Gabriel, that I read about a series of interesting experiments you can do involving eggs?
Wow, really?
It's called the experiments.
Experiments?
Yep.
That sounds fun. Can we try them?
I don't know.
Please?
What's in it for me?
I'll belanja you ice cream.
Ice creams?
2 ice creams.
2 ice creams? Deal!
Okay, so what are we waiting for? Let's go.
Wait! I think we're forgetting something, huh?
Forgetting what?
Oh! We forgot to introduce ourselves to them!
How can we forget that? Well, hello, wanakam.
Ni hao and apa kabar to our experiments! As you can see, we are from St. Michael's Institution, the greatest school on earth!
The Earth? The universe? So what are we waiting for? Let's go.
Wait, Gabriel. Today, we are going to make you so sick of eggs that you won't even want to ever eat your nasi lemak again. So, let's not waste any more time. We move to our first experiment, which is the egg vacuum.
The egg vacuum. So, this is our first experiment, the egg vacuum.
What is the egg vacuum, Gabriel?
Well, the egg vacuum is our first experiment to demonstrate the effects of air pressure on our everyday objects, and in this case, an egg.
Ooh. So, what are we going to do in this experiment?
Well, firstly, we're gonna burn these camphor tablets and put them into the conical flask, and we just put the egg on top and we observe.
Ooh. Wow. 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 I don't get it, Gabriel. How did that happen? Are you a magician or a con artist? What tricks do you have up your sleeves?
It's science. You see, what we did was when we burned the camphor tablets, what happened was that combustion occurred. And combustion, as we all know, uses up oxygen. So, when oxygen is used up in the conical flask, a lower pressure region is created inside the conical
Oh,
flask.
so the atmospheric pressure, which is higher, pushes the egg into the conical flask.
That's right.
You're a genius, Gabriel. Okay, so what do we have next? I can't wait.
Next is the inertia egg. So, this is our second experiment, which is entitled inertia egg.
Inertia egg?
Yep.
What's inertia egg, Gabriel?
Well, firstly, inertia is Newton's first law of motion that explains the ability of an object to remain at its state of rest or uniform motion.
Oh, but that sounds so hard to be put into an experiment, Gabriel. I bet it's as hard as those math equations I can't solve.
It's super simple. Well, let's just start with it. So, firstly, we have our eggs on the cup holders, and the cup holders are on the
Cake tray.
tray, and they are on
3 cups.
the 3 cups. Okay.
So what do we do?
What we're gonna do is that we're gonna pull this cake tray away as fast as we can,
Oh.
and then we just observe what happens. So let's start.
Wow, Gabriel. The eggs fell into the cup.
Yep.
How
Do you
did
know
that
why?
happen?
It's because of inertia. Remember?
Oh, inertia. So the eggs have a tendency to remain in its motion.
Yeah,
so
and the
it
gravity
falls into.
pulls it down.
What happens if we pull the cake tray super slowly?
Let's try that.
Okay. So should I do this?
Yeah.
Thank you. Wow.
Yeah.
What's the difference in this observation?
Because when the cake tray is cooked slowly, frictional force occurs between the egg holders and the cake tray, and the eggs
Accelerate. Oh,
accelerate.
I see.
Yeah, that's the word.
Oh, so they accelerate and fall off.
Yeah.
Oh. Now, Gabriel, you know what time it is?
What?
It's time for our third experiment, and it's my turn to shine.
Okay. So what are we gonna do? More physics?
No, it's chemistry this time. So, do you know that an egg can take part in a chemical equation?
Reaction, you mean?
I mean reaction. My bad. So, an egg is actually an organic carboxyl acid. An egg is an organic carboxyl acid which allows it to take part in acidic reactions. And as we know, the acids are able to react with metal carbonates to form carbon dioxide, salts, and water. I repeat, acids can react with metal carbonates to form salt, carbon dioxide, and water. Hey, what are you doing, Gabriel?
I was bored.
So why don't we just get into the action then? Now we observe.
Oh look, I see bubbles.
Yes, those are bubbles, or more accurately, those are effervescences of carbon dioxide gas. Carbon dioxide gas is released when vinegar, which is acetic acid, and egg, which is calcium carbonate, undergo an acid metal carbonate reaction. So, why don't we call upon one of our friends to take a closer look and complete these chemical equations?
Any volunteers? Hello.
Hello.
Welcome to our experiment.
Oh, so this is what you're calling the eggs experiment.
Yes, it's the experiment.
Experiment.
Okay, so we want you to complete this chemical equation over here about the reaction between egg and vinegar. I give you a clue though. You can take a closer look at these bubbles.
Okay.
And I re-mentioned that eggs, which are acetic acid or ethanoic acid, reacts with calcium carbonate to form salt, carbon dioxide, and water. So can you complete this equation?
I'll try. Let's see. Okay. I guess I'm right.
You're doing well. That's
That's
right. Let's give a round of applause to our smart friend over here.
Thank you.
Thank you.
Okay, thank you.
Thank you. So, do you know what will happen if we leave this apparatus for a day or two, Gabriel?
No, I don't.
Voila! What do you see?
A boiled egg?
This is not a boiled egg. Is a boiled egg this bouncy? Well, the entire egg shell will dissolve in the vinegar and it will form the only cell membrane of the egg, which will be bouncy, and you can use it as a basketball.
Wow.
Nah, I'm exaggerating. You can actually bounce it up and down. So, and if you put it on a torchlight, you can actually make disco balls out of it.
Really?
Yep.
With all the colors?
Yep.
Wow.
So, I think I've had a lot of these complicated equations and eggs for experiment for today. So why don't we move on for something simple, Gabriel?
Like what? Frying eggs?
No, frying eggs. We're not having a cooking show here, please. We'll learn how to differentiate between a raw egg and a boiled egg. See, I actually found these eggs and I actually mixed them up. One is raw and one is boiled. How am I supposed to differentiate? Do you know?
I'm not sure, but I've read about that somewhere. Oh, you spin them, right? And you try to stop it?
Yep, that's right. So why don't we do it? See? Continues to move. So this is our raw egg and this is our boiled egg. How do we know? You see, the raw egg center of gravity changes as the white and the yolk of the egg moves around in circles, causing it to produce a wobbling motion. This is different from the boiled egg, which can move freely. And even when you stop it, the boiled egg stops faster than the raw egg. This is because the raw egg has two different inertias. The yolk has a different inertia and the white has a different inertia.
Wow, I didn't know that.
Yep. Gabriel, do you think eggs are strong?
Duh, eggs are so strong.
Nah, I don't think so. Eggs are weak like you. They aren't strong and macho like me. See?
Oh! Hey, what did you do that for? No more ice creams for you.
See, this egg is actually, there's nothing in here, so there's nothing out here too. Okay. So, I prove that eggs are weak. Now it's your turn to prove that eggs are strong.
Fine. This is our last experiment, and we are going to demonstrate the strength of these 3 eggs. So what we're going to do is that we're going to stack books up. Oh, it's okay.
Wait, Gabriel, patience is a virtue.
Okay. Here comes the first book. 1.
How heavy do you think these books are?
Approximately 2.5 kg.
2.5 kg? Oh, that must be heavy.
3,
4,
5,
6,
7,
8.
9.
I bet they're gonna give up any moment now.
No, eggs are strong.
10.
And 11.
Wow!
See, I proved you wrong. Eggs are strong.
Sure you did! Can I try to carry this?
Yeah, sure.
Oh my god! These are heavy! Oh my god! Ouch!
So, why do you think eggs can stand the weight of all the 11 books?
I think you did magic again though.
No, I didn't. Think
But-
harder.
I think I found it. I think the shape of this egg is the clue to how it withstand so much of weight. The egg is dome-shaped, means no one point of this egg withstands this entire huge weight.
That's right.
So the weight is equally distributed around the surface of the egg, allowing it to compress evenly. So, you know what's the sad part now, Gabriel?
What?
We have come to the end of our experiment today.
Aww.
So, you still owe me an ice cream.
No, I don't. You cracked the egg on my head.
That was one ice cream. Remember you said 2.
Fine. Let's go.
Wait, I think we forgot something again.
I know. Bye, guys.
No, not that.
Yeah.
We forgot to answer our first question. Do chickens come from eggs or do eggs come from chicken?
Oh, yeah.